So we need to determine the coordinates of the point trisecting the line segment joining the points -1, 2 and -3, 4. So let us begin. Let's consider 2 points A and B. So A has the coordinates -1, 2. And we have B as coordinates -3, 4. So here we have to find out the coordinates of the point that's trisecting the line segment. So that means what we'll do, we'll suppose that there are 2 points on the line segment. We're going to name them as C and D. Let's say C has the coordinate x1, y1 and D has the coordinate x2, y2. Now here, these 2 points C and D are trisecting the lines. That means the length of AC will be equal to length of CD and that will be length of DB. Now since these 3 lengths are equal, we will suppose that these 3 lengths are equivalent to, let's say, some constant lambda. So this is a supposition. Now what we can say here, that the point C is dividing the line segment AB into 2 ratio, and the ratio AC is to CB. AC is to CB. And what is AC? So here we have assumed that AC, that's lambda. And what's CB? CB is nothing but CD plus DB. So that was going to be 2 lambda. Now that means AC is to the ratio of AC to that of CB. That's 1:2. So we can read out a diagram here. In other words, we can see that C divides the line AB in the ratio 1:2. Now, to find out the coordinates of C, what we'll do, we'll use the internal section formula because C is dividing AB internally. All we have to do is we'll take 1 and multiply it with B, and we will take 2 and multiply it with A to get the coordinates of C. So let's find out. So here C, which is given by x1, y1. To find out the x coordinate, all we have to do is take 1 and multiply it with the x coordinate of B, so that's -3, and add it to 2 times the x coordinate of A, so that's going to be -1, divided by sum of the ratio, so that's 1 plus 2. To find out the y coordinate, we'll take 1 and multiply it with the y coordinate of B, so that's 4, add it to 2 times the y coordinate of A, so that's going to be 2, divided by 1 plus 2. Fine. So that will be equals to, so we have -3 minus 2 divided by 3, and the x coordinate will be 4 plus 4 divided by 3. So that gives us the value -5/3, 8/3. So this is going to be the coordinate of point C. Next, what we'll do, we'll try to find out the coordinate of point D. Since we have already chosen that AC is lambda, CD is lambda, and DB is also lambda, this time we will say that our point D, this is going to divide the line segment AB in the ratio AD to that of DB. Now what's AD? AD is nothing but the sum of AC plus CD divided by DB. We'll substitute the value of AC. We've already assumed AC is lambda, so we have 2 lambda divided by lambda. Here lambda and lambda gets factored out, so we have the ratio 2:1. So we can say that point D, that's we're concerned with point D. So point D divides the line segment AB in the ratio 2:1. Okay, now that we have the ratio in which D divides AB internally, we can apply the section formula to obtain the coordinates of D. The rule remains the same. We'll multiply 2 with B and 1 with A. So let's begin by computing the x coordinate of point D. So we have considered x to having the coordinate x2, y2. So here x2 will be simply, we'll take 2 and multiply it with the x coordinate of B, so that's -3. Add it to 1 times the x coordinate of A, so that's going to be -1, divided by the sum of ratios, so that's 2 plus 1. Then we have the y coordinate, so we'll take 2 and multiply it with the y coordinate of B, so that's 4. Add it to 1 times the y coordinate of A, that's going to be 2 divided by, now we have the sum of the ratios in the denominator. So let's simplify this. So we get -6 minus 1/3, and for the y coordinate we have 8 plus 2/3. So that's going to be -7/3, 10/3. So this is the coordinate of point D. And finally, we can say that therefore the coordinates of point C will be -5,3, 8,3. Coordinates of D will be -7/3, 10/3. And these are the 2 points which are trisecting the line segment AB.